Okay, after our bell exercise, we're going to go straight into the lesson. Okay, so problem 1 states what are the solutions of the rational equation. And we note that we've got fractions, and on every one of these fractions we've got an x in the denominator. So we know we're dealing with rational equations, right? So what's the first step of solving these? We're trying to get this down to x equals some kind of number. Or maybe we'll end up getting two numbers. If we factor out a trinomial into two binomials, we might end up with two answers. So what's our first step? Well, in all of these, it's to try to clear that denominator. And when we start clearing, the first thing we have to do is factor. Factor, factor, factor. So I see right there, there's my favorite thing in the world in math is a difference of two squares. It's so easy, because what do? We can rewrite that as x plus 3 times x minus 3. That's just the rule, the difference of two squares. Now everything's in its simplest terms, right? So our next step, and there it is right there. They rewrote it. So this is where we're at, right there. So our next step is to look at all of our denominators, and the same thing we did as yesterday, but now our terms are just a little bigger. We're going to multiply by each denominator to clear all these denominators. So look at what we have. Well, we've got an x minus 3, an x minus 3, and an x plus 3, and another x plus 3. So we really just have two binomials here that we're dealing with. X plus 3 and x minus 3. So multiply each side by both of those binomials. X minus 3 times x plus 3, and same thing over here. Okay. Now when you do, it's like distributing both of these terms to each term on each side of the equal sign. So this x minus 3 times x plus 3 is going to go up here to the 2. Let's see if I can delete that. There we go. All right. So now I've got 2 times x minus 3 times x plus 3, and over here, let me see if I can shrink this. I've got x plus 3 times x minus 3. I'm going to copy and distribute to each one of those terms right there. Let me remove my equations. And it's a little hard to see, but it's there. Okay? So I distributed that to both of those terms on the left side and to the one term on the right. Now let's start canceling. The most fun thing in the world is to find what matches and get rid of it. So the x minus 3 goes away on the right, and the x plus 3 goes away on the right. And the only thing left standing is our lonely number 2. See that? Now let's work on the left side. So I've got an x minus 3 down here, so I can get rid of the x minus 3 up there. And I'm left with x times x plus 3 for my first term. And then on the next term, we can factor out the x plus 3. And we're left with x times x minus 3. So let's clean this up nice and pretty. There it is right there in this step. So we've got that x times x plus 3, there it is, plus x times x minus 3 equal 2. So see, we just cleared all of those denominators by multiplying by 1 each of a denominator. Any questions to this point? Next step is to distribute both of those x's, because now we've pulled it apart, we simplified as far as we can go. Now let's put it back together and see if we can start solving for x. So now we're going to distribute this x to the first binomial. So it's going to be x squared plus 3x, and the second term will be x squared minus 3x equal 2. And there it is in the next line. And then our next step is to combine like terms. So I see I've got a 2x squared. X squared plus x squared is 2x squared. And then 3x minus 3x, well, those go to 0. So I'm just left with 2x squared equal 2. It's turning out nice and pretty, isn't it? Now we are just still solving for x. So now get rid of your 2, divide each side by 2, and you get x squared equal 1. Well, we know x squared equal 1. You take the square root of each side, and you get the x equal positive or negative 1. So that's our answer, positive or negative 1. But we need to decide, is this a real solution or an extraneous solution? Now remember, a real solution means if I put this number back into the original equation and check, it comes out a true statement. An extraneous solution means you put that number back into the original equation and it made a false statement, or it made, say, an undefined fraction. So let's look here. We've got positive, negative 1. So let's plug in positive 1 up here. 1, 1, 1, 1, 1, 1. So you've got 1 over 1 minus 3, so that's a negative 1/2, plus, and then 1 over 4, 1/4. Does that equal, let's see, 1 squared minus 9 is 2, negative 2/8, which is negative 1/4. Yes, that checks, because negative 1/2 plus 1/4 is negative 1/4. So negative 1/4 equals negative 1/4. So yes, positive 1 checks out, so it's a solution. Okay, and they've already done this down here. All right, now when they plug in the negative 1, he also checks out to be a true solution. So they are both real solutions. Positive, negative 1 is our answer. Okay? Any questions so far? Not bad. I like this stuff. Whoops, I need to grab that. All right, so let's look at our next problem. B, now they're giving us a more complex number to work with. So if you look, let's see, what can I factor out? That's the first thing we zero in on, is what can we factor. And I see this guy right here, this trinomial. Well, that's not an issue for us. We know that's going to be x plus 1 times x plus 2. All right, and if you forget, just do your magic x. Y factors of 2 add up to be 3. It's 2 and 1. So most all of these are going to be those simple things where you should just see it when you see the trinomial. So it's going to be x plus 1 times x plus 2. Now, when we look at these, we know this is going to be x plus 1 times x plus 2. Now let's look at everything that we have. We have an x plus 1. There's 1 that we have to clear, and an x plus 2. We have 2 of those. So really, that's what we're going to multiply both sides by. 1 each of our denominator. And it should clear all the denominators. Okay? So, this is what they've done in this step right here. They're multiplying both sides by x plus 1 times x plus 2, or vice versa. And then they did it again right there in red. Okay? So when they do that, they're not even showing you how they distributed and canceled out. They just go straight to the next step now. Okay? But I'll fill in what they did. So when they multiply this one times x plus 2 times x plus 1, and you already have an x minus 1, and then again you're going to do x plus 2 times x plus 1 here. So what cancels out? Your x plus 2's and your x plus 1. And you're left with that 1 x minus 1 in the first term. In the second term, we can only factor out an x plus 2. So we're left with 2x times x plus 1. Okay. And on the right-hand side, well, this becomes part of that numerator because we're multiplying them all together. And what cancels out? An x plus 1. So what's left over? X plus 2 times x minus 1, which is right there. Okay? So that's all there is to that. Now we've canceled everything out. Now we've got to start putting it back together. So I see one distribution that we have to deal with. 2x times x is 2x squared, and 2x times 1 is 2x. So do that. This is going to be 2x squared plus 2x. Right? Now combine your like terms. You're going to have 2x squared there, and then plus 2x. Well, 2x plus x is going to be a 3x minus 1. Okay, so that's your right side. And over here, just FOIL this out, and you get x squared plus x minus 2. Now we still have to get it down to 1x, right? So let's subtract minus x squared minus x minus 2 from both sides. And when you do, this all goes to 0. Sorry, that was a plus 2. I'm in a hurry. Okay, so then you get first term x squared plus 2x plus 1 equals 0. Okay, and that's where we're at here. Now we're down to that simple little trinomial again that we can factor so quickly. That's going to be x plus 1 times x plus 1. It's x plus 1 squared, right? So what makes this true? When x is equal to negative 1. So now we've got one solution, x equal negative 1. So let's go back to our original equation and check for extraneous. Well, when we plug in this negative 1, well, we know that's going to be a positive. So let's see, that's going to be a real number. That's going to be a real number. And when I put in a negative 1 here, I get negative 1 plus 1, 0. I get an undefined fraction. So I don't have to go any further because I created an undefined fraction with that negative 1 that automatically makes this an extraneous solution. Okay, because it makes a false statement. Okay, any questions? So if you plug your solution back in and it makes a false statement or it makes an undefined fraction, like 0 in the denominator, then it's extraneous. There's no solution. Okay? All right, well, I should point out one other thing. I forgot to begin. What can't x be when we start? You should always take a peek at that. X could not be a negative 2, and x could not be a negative 1. And when we got down to this 2, we say that's extraneous solution. But because we said, because it makes an undefined number fraction, we say there's no solution because it creates a 0 in a denominator. Okay, so it was extraneous, but then when you look further, there's just no solution because that doesn't work out. It creates an undefined number. All right, so no solution. All right. Problems 1, 2, and 3 on your 8-6 goes with that. Okay, problems 1, 2, and 3, and you'll work those at home tonight. Problem 4, X out. I've got a different word problem for you. Problem 5 and 7 we'll do in class tomorrow on the graphing calculator. So now I'm going to move on to 8, 9, and 10. And let's look at problem 8. And I'm just going to teach this by doing it. So you'll have the first one done. And guys, you did this 1,000 times since Algebra 1. You've done this in Algebra 1. This is just a literal equation. They want you to solve each of these 3 equations on 8, 9, and 10 for the given variable. For number 8, it says capital F equal mv squared over r. And they say solve for v. So we're solving for that variable right there. That means v is going to remain, and we've got to get rid of everything else on the other side. So let's start solving. So we've got f equal v squared over r. So the first thing we need to get rid of is this r. So I'm going to multiply each side times an r. And that cancels out. Next step, I'll do in blue. So now I've got r times f equal mv squared. Now I'm still solving for v. So I've got to get rid of my m. So divide by m and divide by m. And these cancel out. So now I'm left with v squared equal r times f over m. Now I just have to take the square root of each side. And these cancel out to v equals the square root of r f over m. And that's your answer. You're just solving in terms of the variable they gave you. So on number 9, super simple, you're just solving that one for d. So you got to clear everything but the d. 10, you're solving for r. Any questions on those? So that will be your homework. 1, 2, 3, 8, 9, 10. Now let's look at the next problem, the word problem. If I tell you the sum of the reciprocals of 2 consecutive even integers is 5/12, write an equation that can be used to find the 2 integers. Then find the 2 integers. So when you think about the sum of 2 reciprocals, what if it even wasn't there? Let's back up even to Algebra 1, where you did a bunch of these in Algebra 1. We said the sum of 2 numbers. How about this? The sum of 2 consecutive numbers is equal to 12. How about 11? The sum of 2 consecutive numbers is 11. You could figure this out in your head, right? But let's do it mathematically. So we know we've got 2 numbers, and they're consecutive. It means one right after the other. So wouldn't that mean one number is x and the next number is x plus 1? Right? See, 2 consecutive numbers, x plus 1 is equal to 11. Whoops, wrong one. All right, so what would you do? You would say, well, that's 2x plus 1 equal 11. 2x equal 10. X is equal to 5. Oh, well, the first number is 5, and the next number is x plus 1, which would be 6. Oh, my 2 numbers are 5 and 6. When you add these 2 consecutive numbers, you get 11. Check. Well, now we're not talking about consecutive numbers. We're talking about consecutive even numbers. So let's see, 2 consecutive even numbers. So if one even number is x, and I add to that the next even number, well, what would we have to do? X plus 2, right? Because it's 2 further. the even numbers is x plus 2, is equal to 14. It's in the way you set it up. So two consecutive even numbers, there's the trick right there to make even. So let's see what it is. 2x plus 2 equal 14, 2x equal 12, x equals 6. Oh, the first even number is 6. The next even number would be 6 plus 2 is 8. 6 plus 8 does equal 14. So the even part is to say, oh, you just have to add 2 to that. But now this problem's not talking about integers. They're talking about reciprocals of two consecutive even integers. So if I had 6 and 8, now I'm talking about the reciprocals. 1 over 6 plus 1 over 8. So this becomes my x, and this becomes my x plus 2 is equal to 5/12. Does everybody see that? I'm solving it down there. So if I have 1 over x, that represents my first reciprocal. And the next even reciprocal would have to be 1 over x plus 2 is equal to 5/12. So there's the setup of your problem, and I want you to solve this tonight. There's one just like this on your test. All right, so you'll do that, and we'll do one calculator assignment tomorrow, and that'll wrap up this chapter. I've got your study guides, so that concludes the video. Thank you for watching.